Over 130 years of experience in designing, developing and building components and ships for the dredging industry has made IHC Holland a world market leader. Highly trained and skilled personnel work day in, day out on the research and development of new dredging technologies. In the past 20 years, IHC Holland has built over 80 trailing dredgers for private contractors as well as government bodies all over the world. In the 90s, very large reclamation works and the building of airports in the sea meant bigger dredging jobs, which required larger dredgers. In 1994, IHC Holland designed and built the Pearl River. She can carry 17,000 cubic meters of soil in her hopper. She was the first jumbo hopper dredger in the world. Up to now, 80% of all jumbo hopper dredgers have been built by IHC Holland. Especially for maintenance, dredging in narrow or shallow waters, and deepening of ship channels, IHC develops medium-sized and smaller dredgers. Special types of ships can, for instance, be used for dredging gravel or even for cleaning up oil spillages. One of the world's largest trailing suction hopper dredgers is the Queen of Penta-Ocean. She has a hopper capacity of 20,000 cubic meters and has been built for Penta-Ocean Construction Company in Japan. From the bridge, the dredge master controls the large gantries and winches that lower the suction tubes into the water. It is during the sea trials that the Queen will be dredging for the first time. The sliding piece is descending with the suction tube along the ship's tracks down to the suction tube inlet. It takes a return to the building process to suggest the scope of the mammoth task ahead. The Queen's two suction tubes are 80 meters long each, with a diameter of 1.2 meters. They can operate at depths down to 60 meters. The suction tubes of the Queen are both fitted with a submerged dredge pump. This will give her extra suction power. The sliding piece, the suction tube not yet attached. Gantries lower the suction tubes into the water and hoist them back on board when they've done their work. A suction tube in operating position, attached now to the sliding piece. Each suction system utilizes a submerged dredge pump in combination with a double-walled inboard dredge pump installed forward in the ship. The inboard dredge pumps have a power capacity of 6,000 kilowatts each. Just as all other dredging components, they are designed and manufactured at IHC workshops. The impeller is fitted into the pump at the shipyard. The two pumps are installed during the shipbuilding process. They're constructed of heavy-duty cast steel for extremely heavy-duty work. When the two suction mouths have touched down on the seabed, dredging can begin. Thanks to the enormous capacity of the four pumps, intake speed is very high. The mixture intake is fed into the hopper through the drop chute and is well distributed along the entire length of the hopper. The dredge master controls maximum production by adjusting the density and velocity of the dredge mixture. This can also be done by automatic control. The swell compensator incorporated in the suction tube's handling cable keeps the suction mouth at the desired pressure on the sea bed, irrespective of ship's motion and irregularities of the sea bottom. Under normal operating conditions, it takes about 1 hour to fully load the vessel with 30,000 tons of soil. The seawater drawn in with the soil is flushed overboard by the 2 adjustable overflows in the hopper. Once the hopper is fully loaded, the gantries hoist back the suction tubes and the Queen sets sail for the discharge site. Her speed is 16 knots. Different ways are developed to unload the soil. Some dredgers have bottom doors in their keel. When these doors are opened, the soil is dumped on the sea bed. The Queen is fitted with 26 hydraulically operated IHC conical valves. The dredge master on the bridge can open and close them in groups divided over port and starboard side. The inboard dredge pumps draw water onto the cargo, providing extra liquidity for the discharge of the material. The valves are put in place in the hopper in the earliest building stage. They're made of heavy-duty steel, and placement is another delicate operation. Conical in shape, the valves have to fit exactly in the middle of the valve opening in the bottom skin of the dredger. Opening and closing the valves is assisted by guiders. The conical valve is fitted with a rubber seal. When the valve is closed, a special valve sheet welded into the bottom hull seals it as tight as a drum. Discharging is also possible by using the bow discharge installation. In the heart of the ship, there's a complex system of pipes and valves through which the soil can be transported to the ship's bow connection. The soil in the hopper is made liquefied by pumping in seawater under high pressure. By coupling the bow connection to a floating pipeline, which is connected to a shore pipeline, the soil can be transported to the shore. In this, the dredger's inboard dredge pumps, now coupled in series, pump the soil to the bow discharge connector. A third is the rainbow method, where the material is sprayed to a designated spot ashore under high pressure. Sea trial successful, and the Queen of Penta Ocean is on her way to the first assignment, a reclamation job near Singapore. During her lifetime, IHC will be there when needed, with its unique full backup support. Crew training, technical support, rapid delivery of spare parts, just to name a few. Anytime, any place, anywhere.